Okay, last lesson for this week. Hopefully you did well on your test. So a while back we had talked about what happens when you scale up your shapes. So if you have a small square and you triple the size of it, what happens to the area? It doesn't just increase by the same amount as your dimensions would have, and what happens to the volume? And I think if I remember right, it's been a while now, but I think if I remember right, I told you that there's a trick. Well, some of you started asking, and there's actually a trick to figuring out your area and volume based off of the exponent. Before I keep going, I realized that I didn't do a joke or a riddle at the beginning, and I apologize. I'm running out of time here at school, and so I'm going to skip that, and we're just going to run right into the lesson. So hopefully the fact that it's Friday and you're soon done with school can be your positive element of today. So the effects of scaling on a shape. So with dimensions, there's going to be three parts here. There's going to be just your regular linear, just your line measurements. There's going to be your area, and then your volume. So you have your linear, which then for that, you're just going to have your simple scale factor. So for example, between 1 and 2, what's your scale factor? It's going to be whatever your scale factor is. For that, it is 2. 1 times 2 gives you 2. 1 times 4 gives you 4. So your scale factor is all you do. That's going to be your linear ratio. So that's going to include your perimeter. The other thing is going to change. So, for example, this one, your perimeter is 1, 1, 1, 1. That's 4. Your perimeter is equal to 4. For this one, 2, 4, 6, 8 is your perimeter. 4. So 1 times 2 equals 2. 4 times 2 equals 8. So this is going to be 4, 8, 12, 16. The perimeter is equal to 16. 1 times 4 equals 4. Therefore, 4 times 4 is equal to 16. So it's just your perimeter increases by your scale factor. That's fairly quickly. So if you double it, that means your perimeter is going to double. For the area, then, you take your scale factor and you square it. So, for example, what is the area here? Well, 1 times 1 equals 1. So the area equals 1, and 2 times 2 equals 4. So the area equals 4. 4 times 4 equals 16. So it goes 1, 2, 16. The way you do that is, what is your scale factor between 1 and, what do you need to multiply to get from 1 to 2? And that is 2. So your scale factor squared. 2 squared is 4. Sure enough. There you have it. Your scale factor is 2. So therefore, scale factor squared is going to be how much bigger your area is. So let me just do this. 2 squared is 4. So that means your area will increase by 4. 1 times 4. Going from here, 1 times what equals 4? It's 4. So your scale factor is 4. 4 squared is 16. 1 times 16 gets you to there. Now let me just show you this thing. So between this shape here and this shape, you double it. Your scale factor from 2 to 4 is 2. So 2 squared is 4, because there's a square here. So 2 squared is equal to 4. That means your ratio of change is going to be 4. The area of this is 4. times 4 equals 16. So your area, you just square your scale factor. Then for your volume, you take your scale factor, and since it's three-dimensional, you cube it. So, for example, from this one, let me just go from this one here to the biggest one. So the volume of this shape here would be 2 times 2 times 2, length times width times height, that is 8. This shape here, 10 times 10 times 10, would be 1,000. So how do you get from 8 to 1,000? Well, here's the thing. What is your scale factor going from 2 to 10? 2 to 10 is what? What is your scale factor for that? It's actually, what number do you have to multiply? It's times 5. So 2 times 5 gets you to 10. So your scale factor is 5. The scale factor is a word for just talking about how much it increases. If it's 1/2 or 2, you have to determine that. Going from one shape to another, what do you have to multiply? So your scale factor is 5. 5 cubed. 5 times 5 times 5 is what? It's 125. So what this is saying is that in order to, the ratio of the volume from this number to this number is times 125 is your scale factor for that. So you can actually do that. 8 times 125. Well, I can just tell you 8 times 25 is 200. And 8 times 100 is 800. Add this together, it does equal 1,000. So it's just a simple way of figuring it out faster rather than doing all the work that you were doing before. So we're going to do two things, and I'm just going to jump right into the practice set. I'm going to pick a couple problems out of there, and we'll do those and then be done. Okay, so I picked 3 letters, B, D, and H for the problems that we're going to figure out. So first thing that for B is you have a wallet-sized photo and a 5x7. The area of a wallet-sized photo is about what fraction of the area of a 5x7? And I'll just tell you that the scale factor to get from this one to this one is you have to multiply it by 1/2, right? So the scale factor between these two is 1/2. Now, that's going from this shape here to this shape. So when we look at scale factors, we're going from this one to this one. Would have flipped it around, but would have done that. Scale factor is 1/2. So if the initial thing is 1/2, that's your scale factor. What is your area? Your area, remember, was area is equal to scale factor, which is 1/2, square that. So 1/2 squared is 1/2 times 1/2, which is 1/4. So your area scale factor is 1/4. So whatever the area is here, you would multiply that by 1/4 to get your area for this one, right? So it's just a scale factor number that you can then use to multiply back and forth. So that's all they're asking there. The area of the wallet-sized photo is about what fraction of the area of a 5x7, and that is, it's 1/4. This guy right here is 1/4 the area of this guy. That's all it's saying. D then, find the scale factor of the smaller rectangle to the larger rectangle. So here's your little rectangle, here's your big one. What's the scale factor? You might be, where's the extra measurement? There's no measurement to compare the 4 to. Well, the height then, compare the height. And there's 2 and 6. What is the scale factor? How do you get from 2 to 6? It's 3. Times 3 from the little guy to the big guy. Then they want to know that what is the scale factor, find the ratio of the perimeters and areas of the larger rectangle to the smaller rectangle. So the ratio of the perimeters is times 3. which way are we going? From the larger to the smaller. So back up, going from larger to smaller. 6 to 2 is what? You multiply by 1/3 for the perimeter. The perimeter is 1/3. The area is 1/3, except you have to square it. So that means it's what? It would be 1/9. So in order to figure this out, you would figure out the big rectangle's area multiplied by 1/9, and that would get you the smaller one. And if you look at it, it's about right. 1, 2, 3, 4, 5, 6, 7, 8. About 9 of these little ones could fit in the big one. Then the last thing, I don't think it tells you to figure out the volume. Nope. So the last thing here is letter H. So you have two balloons. You have a balloon with a 6-inch diameter, and you have a balloon with a 6-inch radius. So you have to ask yourself, what is the scale factor here? And the linear measurement between this thing and this thing. What is the linear measurement? You'd say, what, 6 times 1 equals 6. Yeah, but you're looking at the diameter here. What's the diameter here? It would be 12 inches. So the scale factor is 6 times what? 2. So the scale factor for the linear measurement is 2. For the area, it would be 2 squared, which is 2 squared is 4. And the volume is equal to 2 cubed, which is 8. So that's the scale factor. And you have to ask, the question is, what are they wanting to know? How much water does a 6-inch radius balloon hold? Well, what is that? Is that area? Is that perimeter or linear measurement? Or is that volume? And it's volume because they're asking how much it can hold, how much fits in a 3D shape. So if a 6-inch diameter balloon holds a pint of water, this thing right here, 1 pint. How much can this balloon here hold? What's the scale factor? It's 8. So 1 pint times 8 would equal 8 pints. And you could write that 8 pints. What is that? 2 cups is 1 pint. 2 pints is 1 quart. So that would be 1 gallon right there. And we can hold 1 gallon of water. Difference there. Okay, that is. I think that should make sense for you. If not, go ahead, shoot me some questions, and yeah, hopefully you can figure it out. Okay, have a good one.